Good morning, everyone. To begin with, the project was born after the demand for our Vice President to reduce operational costs through improvements in operational efficiency. To do this, we applied a combination of methodologies, lean thinking methodologies, and system thinking methodologies. This allowed us to reach the conclusion that the lack of a robust scheduling process has been the root cause of our inefficiencies. Once the diagnosis was completed, we got the approval to initiate the project of improvement of the scheduling process. After the conceptualization phase, we realized that we manage a complex system with many interacting parts, with some simple rules, and many constraints. So we decided we needed a more sophisticated tool to reach higher efficiencies. We realized that Excel was not enough. The scheduling process was mainly manual, and each planner worked with its own set of resources. And this was a problem because we were never able to reach a global optimum. Both the diagnostic work and the pilot test had been carried out in Rincón de los Sauces, an oil field located in the province of Neuquén in Patagonia, Argentina.
I want to draw back a little bit, if that's okay. I know you did a long presentation, John. Thank you for that. But just talking about C7, Continente 7 is a very awkward name to say in English, so we just shorten it out to C7. A little bit about us. Continente 7 means the seventh continent. So basically, we have 6 continents. We have the 5 in the Olympics and the Antarctic. And basically, the 7th continent is where we can build virtual worlds to test things there and not necessarily harm the real world, but test it there and optimize the real world. Of course, in the US, that doesn't work because you guys split North America from South America. But anyway, we couldn't change the name then. We have, the last thing I'm going to say, we have 2 divisions. We have one called Simcastia, where we use data science for the demand forecasting side, neural nets, someone talked about machine learning techniques and stuff like that. And there we work globally with companies like Unilever and ABI. And then we have Simcastia, that's why we've heard a lot of different names in here, Continente 7, C7, Simcastia. It's all the same. Simcastia is our brand where we work with simulation and optimization. And color note, we do have an free online. Do we have some Spanish-speaking people here? Raise hands, please. Definitely 2 over there. We already talked to them. We have a free massive online course on multi-paradigm simulation based on AnyLogic. It's free. You can ask access for that. And another color note: who in here entered run the model in the previous 2 months? I know that we are going to change. You guys are going to do a very great thing with the cloud. But if you look us there, we are kind of number 2 after Andre, who is number 1 model posting in Run the Model. Anyway, going back to the problem, so we're talking about maintenance scheduling, right? The reason why we needed to use something like AnyLogic was due to these 4 different reasons, right? We needed flexibility. Argentina is a very specific country with very specific politics and very specific behavior, so we need to do something tailor-made for them. The other thing is, of course, we're talking about scaling. We're talking about a scaling tool. Think that before this, the scheduling was done by people, right? Using a spreadsheet, and every single day they were working with 100 different tasks that they had to program within the week. And the other thing is that they had to schedule things that used different teams, different resources, but they had different planners scheduling different sets of resources. So the communication between them was not very good. It was not centralized. It was completely decentralized. So, of course, we need to talk about an optimization technique. So that's reason number 2. And the other thing is, as I'm going to go with the slides, the agent-based simulation and the multi-paradigm simulation comes kind of apparent, specifically the agent-based simulation. So that's a very good thing that you guys have in AnyLogic. And of course, if we are developing a tool, it needs to be eye-catching. It cannot have an interface of 1990s. Okay? So we need to do something that has some kind of a visual power. So it all boils down to this very simple equation that presents no additional complexity. What we're trying to do is reduce costs. Right? We have resources, and the thing with oil and gas is that sometimes you have a task, something is broken, and the asset is not producing any oil until it gets fixed. Or sometimes you have to do something that's preventive. You have to do some maintenance tasks. And once you start the task until you end the order, the asset is not producing. So the second point in there, which is what's production loss, it's a tremendous variable in here that needs to be minimized. Of course, you have extra hours. Of course, you have the hours that the people are not working, which I cannot find the name in English right now, but I think you understand me. And of course, within each of these assets, by the way, you guys have, like, how many assets do you have?
More than 31 assets.
31 different assets?
The country.
Each one of those assets is composed of a lot of different locations, so the movement between each one of those locations is also something important to take into account. Now, I'm just setting you into the problem, right? The actors that you see in the problem are very easy to understand. We have the resources, right, which is a combination of people and machines. We have the positions, the locations that the people have to go in and work, basically. Different locations within the assets. Sorry for the camera crew, I move a lot. I'm an impatient guy, and on top of that, I drank coffee today, so I'm not supposed to drink coffee. And you have a lot of different tasks that they need to schedule all the time, every single day. Okay? So this is clear why we need something that's kind of agent-based or object-oriented, right? Each one of these actors has its own variables and its own behaviors, but resource to resource, the structure is still the same. So that's a beautiful thing to solve with agent-based simulation, right? But anyway, we talked about optimization, not necessarily simulation. So why do we need to do simulation? And the thing that we did is, we didn't go directly to optimization because the problem was very complex. And I'm going to talk just one simple thing that maybe it makes it more apparent. We need to draw a simulation so that on top of that simulation we could have an optimization, which is something that's very common for you guys. Anyway, if you think of tasks, if you think of scheduling, there's a lot of scheduling solutions that directly go to the optimization. That's fine. That's specifically simple. The thing here is that you don't have only tasks. And this is something that we found out while we were doing the process, the project itself. You have orders, you have work orders that start with a task, and the different tasks of the work order are done by different resources, but until you end the last task of that work order, you cannot close the work order. So if the asset has stopped producing, then until you end it, you cannot continue producing again. Make sense? And this is something that was not done before, because again, different programmers were programming different resources. So the communication between them was not as good. Now we're looking at the entire thing, so we have a new agent basically. We have the work order agent that ties everything up. Okay? So basically the optimization process takes this work order and these tasks and all the other agents that I already talked about, and it has a kind of a three-step process. It first starts by locating the most, it qualifies the priority score of each one of those orders, work orders. And it starts with the most critical one to the less critical one. Then on top of that, it's a mixture of, it's a greedy-based algorithm, very simple but greedy-based algorithm that is used for scheduling. And after that, what it's trying to do is trying to reduce the time of the work order itself. Once it puts all the tasks in the schedule, it goes back again and tries to reduce the time of each one of the work orders. Okay? And here, we're going to show you some screens. We're not going to show you a full video. Now, this is strange. We're talking about AnyLogic. AnyLogic is very powerful because you can do very cool animations. There's no animations in this model. Okay? A lot of times we do the mistake of when thinking of maintenance scheduling, hey, it would be very cool to see the people going from one place to the other one, right, and fixing things, and we can see that. The problem is that, again, the use here is a daily use for a planner, right, that the sole purpose of running this planning tool is to get a plan, not to see the evolution and the nice animation. So this time we went directly, and we didn't want to do an animation for them not to use the animation and get the direct output, the direct output and work for that. Instead, we wanted to see how they could use the tool. And instead of doing animations, we started doing dashboards. And I'm going to show you some of the dashboards that you can do through AnyLogic. Of course, this is kind of an input screen. In here, they can play with some parameters. They can tell whether it's going to rain in one of the next few days, because there are tasks that you can do with rain, and there's tasks that you cannot do with rain. Same thing with strong wind, so you can play with some scenarios in here. You can also say, you know what, this resource is not going to be available this day for some reason, and you can play with that information as well. And then for the dashboards, I'm not going to explain all the different dashboards, but again, this thing has to be eye-catching, right? So we're looking at the results in here, the final cost for the run, for the scheduled run. Of course, these are not actual costs because this is something that is planned, right? It's the cost of the plan. And we're looking at different levels of the solution. We simulate 30 days forward, but we're looking at results after 9 days, after 12 days, etc., etc. Okay? And you can get in there and see the utilization for each one of the resources, groups of resources. You can see how the work has been done in each one of the locations. I mean, you can dig as low as you want to with these screens. The problem that we had when entering this dashboard construction is that they wanted more. So we had to do a lot of different dashboards, as you can see. But anyway, I'm gonna skip all of them. And in here we have kind of the output, but in the tool, not the output that they are using, actually. So this is the schedule by each one of the resources, and the schedule by each one of the locations. Right? And again, everything is done through AnyLogic in this case. So fine, we talked about AnyLogic, we talked about the tool itself, but that's not the project. Okay? The project is much more than that. The project, and from here to that part, is the most difficult part, which is the process change. Right? From here to this side, that's the easy part. We just need to do the tool, and we need to embed it and communicate it with their existing systems. So this tool, whatever you see in the middle, which is called cron, is connected to APO. It's drawing data from APO and from geolocation databases that they have, and it's writing the plan every time in APO itself. And there's an internal database also for them to create scenarios. Okay? But again, the sole purpose of this tool is not to simulate, but to optimize. The simulation is just a means for the purpose. Make sense? And of course, they can download some Excel exports as well from the tool itself. Now we're going to go into the results, and whatever Jonathan says is much more important than what I say. So we're going to let him talk about the different results that they got since they implemented the pilot, which was in this location that he mentioned before, in this asset.
Okay, some results. In this graphic, we can clearly see how after the pilot test was introduced, crew effectiveness improved, resulting in an average increase of 11% in work order executions. In this second graphic, we can see how compliance to and fulfillment to our preventive maintenance plan improved after the application of the scheduling optimization model. And therefore, there has also been a prominent reduction of 56% on the corrective maintenance backlog.
Here, talk about yesterday PwC showed us the napkin on Uber. There's also a nonlinear loop in here. If you solve the corrective orders better, if you improve that rate of solution, and if you improve also the scheduling of the preventive side, then the preventive side itself becomes easier because you have less backlog.
Okay, as a result of the different improvements previously mentioned, there has been a decrease of about 50% of oil production losses due to mechanical failures. In this last graphic, we can see a clear comparison of the situation of Rincón de los Sauces assets before and after the incorporation of the brand new scheduling optimization model.
And this is just to, sorry about the camera, but in here, x-axis, we have the percentage preventive tasks that we're able to solve, in the span of 9 days, in the span of 1 week actually. And the y-axis, you have those that are very important, critical by law, right? And all the assets, all the blue bubbles in here are different assets, but the red one and the green one is the same asset before the pilot test and after the pilot test. And an interesting thing about the size of the bubble, which is?
Corrective and preventive maintenance.
You can see the bubble shrunk. And this is that the ratio of the corrective tasks reduced because you were able to solve the backlog because you got better at the scheduling.
Okay, this project have a huge economical impact in Rincón de los Sauces asset, $18 million per year and a net present value of more than $200 million if we could implement it in all the YPF assets in Argentina. Okay, to conclude, we might say that mathematical models developed by experts in the hands of people in charge of decision-making within the companies can lead to greater results and thus more profitable businesses. Thank you.
Very good work. It's very impressive. I have a question about how you use optimization and simulation together. Is there a sequential procedure? So you run the optimization first, then you go to the simulation to get the uncertainty checked, or is a blended procedure? Is it iterative? So you run optimization, then go to simulation, then go back.
So it's actually using both more or less at the same time in the first layer. Let me go back to using both in the same layer. I don't know where I was talking about it. Yeah, here. So the optimization first starts with a prioritization, and there's no simulation in there, just a prioritization based on score. But once it starts using the greedy-based algorithm, it is using the simulation and the optimization on top, and they're going side by side. Let me give you an example. If there's an extra hour that needs to be worked by a specific resource, the next day, that resource has 1 free hour that they don't have to work. So that is currently being simulated. Or sometimes there are tasks that require some waiting time before the next task comes in, but no resources are required. So that, again, comes in through the simulation. So it goes optimization and simulation in one stage. Then it does the third part, which is, again, an optimization side with simulation. And after everything's finished, it does one last simulation to calculate all the KPIs. But that simulation is very simple. It's just following the plan.
And some really great work there. It's fantastic. So just wondering, in terms of resources and time, how long it took to go from sort of concept to pilot for this work, and what sort of resources you used on it?
Don't want to exaggerate, so I'll leave Jonathan to the question of how much time. The conceptualization, since they found the problem until they decided to come up with a solution, and from there, the conceptualization and the development, is that?
What the other companies were doing about scheduling. And then it took almost a year to develop the model. Not for the, for the code, no? Just to refine the model, to test it. We spent a lot of time with the team of Juan Pablo, going to the oil field, talking with people, refining the model. So almost a year for that.
So yes, the first draft, for example, the first operational model was after 3 to 4 months, which is whatever the most patience you can get from a company, right? But then after that comes the iteration side, where you validate with actual use, and then you get feedback from the users themselves, and then you start working on the tool, doing some imperfections. And actually, it's still ongoing, because now they want to centralize everything and improve the integration in a central manner. So we're still going with this. And we have a roadmap of improvements also ahead that maybe some of you are going to ask some questions that are not currently being solved now, but it's part of the roadmap. See you, Luigi. Thank you.